Ready? Okay, thank you, Ms. Joey. So, the last thing we want to look at in quadratic function is quadratic inequalities. And with this, we've come to the end of quadratic. So we're going to do that today and tomorrow, because there are two parts to quadratic inequality. We have done indirectly part of it. Maybe I should have brought this topic before that topic, but it's fine. Remember when we did, remember a few weeks, months, whatever, when we did a rational function? Yeah. Can you remind me of one thing that was very useful in sketching the graph of a rational function? Sign diagram. It's on the board, I guess. Sign diagram was very useful, right? Because with that, you know if the curve is above or below what? The x-axis. So that's why I said maybe I should have brought this earlier so we can understand the sign diagram properly. So we're going to understand the sign diagram properly. We have a 2-page worksheet to practice all the questions from your book. Of course, I just made it more in detail, like step by step. So it's easier, even if you're a beginner, it should be easier for you to do. Understand? So then tomorrow we will apply that in solving quadratic inequality. Okay? We have also done some of the tools in the past, which is factorization. So everybody knows how to factor, right? Everybody knows the behavior of quadratic function. Everybody knows positive and negative definite. Everybody knows when it touches, when it crosses, and when it doesn't touch. All this will really help us in understanding the last two ideas. Understand? So, we will start with sign diagram. However, look at this. If the question, I hope you can see the board. It's not too dark. Okay.
It's okay.
Thank you. Yeah, use a dark marker too. If the question says, find the solution of this, maybe greater than 0, not greater than equal to. Okay? If this is the question, normally you can maybe sketch. If you sketch and you have something like this, we're talking about the region where it is above this x-axis. So we are saying, oh, from here, it is always above. From here, it is always above. If the question is less than, then you are saying, oh, from here, it is always below. So if this is m and this is n, then you will say, oh, whenever x is less than m, right? And whenever x is greater than n for this region. Am I making sense? Ryan, you're not looking at the board. You don't look like you're here. Please focus. And if it is the other way around, maybe for less than, then you say, oh, between m and n, then you consider your m less than x less than n. Am I right? We've done something similar to this as well. Now, it's not every time that you have to actually sketch. What we want to do today is to be able to find a solution with the use of sign diagram. Or let me say what we want to do tomorrow. Okay? So we'll start with that today. I'm just going to go through this quickly, and I'll write you a short note on the whiteboard that you can put in your note. But I'm going to go through this with you quickly. We know what a sign diagram is. It is simply a straight line representing your x-axis and tells you the sign of the value of y on the function. Within this interval, will I get positive number, negative number, or 0? We all know that a function is 0 when it crosses, isn't it? That is the solution. So you only have the 0 and the solution. Understand? Which is where it crosses. Outside this region where it crosses or touches, what happens to the sign? We're not interested in the numbers. We're just interested in plus or minus, because we're only interested in, is it above or below? Above by 1 million distance, nobody cares. Below by 1,000 distance, nobody cares. We just want to know above or below. So this is still part of the behavior of quadratic graph on the xy plane. Am I making sense? So, now, we write a short note. So if you look at this, you see, it's an horizontal line which represents the x-axis. Positive, negative indicates whether the graph is above or below. And of course, 0 means where it touches or crosses. depending on the situation. And you will see that this next picture is familiar. These are all the different types of graphical representation of quadratic function we've discussed, isn't it? The first one where it crosses, here it doesn't cross, here it touches. Can you remind me of something about these three? Positive, definite. Which one is positive, definite? The middle one. What else can you remember about these three pictures? That's correct, by the way. What else can anybody remember about these three pictures based on our study so far? Say that again. Discriminant. So, what about discriminant? You can't just say discriminant. Say that again.
On the last one, the discriminant has to be equal to 0.
On the last one, she said the discriminant has to be 0. Is Carolina right about that?
Yeah.
Yes. And why do you say that, miss?
Because it touches.
It touches. So what kind of roots would this equation have?
Same.
Same. We don't use the word same.
Equal.
Equal and
Real.
real. Because what if they are equal and complex? Okay, remember the last test? Those are some of the things I tested in part A. Okay? Of course, nobody in IB will ask you what is distant, what is distinct, what is discriminant. No. But understanding these terminologies and connecting them makes you understand the whole topic better. That's why I'm testing it. So please, subsequently, that's my format of my test. Okay? So that we can understand the vocabulary involved as well. Okay? Alright. So bear with me if you hate my style of test. It's fine. You can hate me now. You love me later. Alright. What else can anybody remember? So Carolina, you're right about that. What else can anyone remember about these three pictures? Just give us any information.
3 forms to write a quadratic equation.
Say that again.
3 forms to write a quadratic.
There are 3 forms. Okay. What form is this one?
Minus p times x minus q.
So this form, where you have two
Distinct and
something factors.
Linear factors.
2 linear factors. And distinct, of course. Okay? 2 distinct linear factors. This is 2 equal linear factors. You see, these 2 points that we are raising now is one of the things that will help you today. So there's a reason I'm asking these silly questions. Understand? 2 distinct linear factors. 2 equal linear factors. Or we can say 2 repeated. We don't say equal. We say repeated factors. Understand? These are the factors, right? These are the Why do we call it factors? Does anybody know?
Because they divide.
Say that again?
Because they divide.
You can
divide it.
You can divide it. Watch this. Let's say you have 18, right? Can you write 18 as product of 2 numbers either? Give me an example.
9 and 2.
Thank you. So 18 can be written as 2 bracket 9. So we say these are 2 distinct factors. It means 18 can be divided by either of them without any remainder. Okay? In this case, this is actually x squared plus x minus 2. Right? It means if I divide it by x plus 2, I don't get the remainder. If I divide it by x minus 1, I also don't get the remainder. So these x minus 1 and x plus 2 are factors of this quadratic function. That's why we call them distinct linear factors. And they are linear because, of course, they are linear. Right? The highest power is 1. Does that make sense? So here, we have the factors, but they are repeated. Just like if we break 4 into 2, what do we get? In the format that Ada has just given us. If the number was 4, what do we get? 2 bracket 2, right? So it means 4 has 2 repeated factors. And that's factorization, of course. It doesn't mean that's the only way we can write 4. Am I making sense, please? All right. But in this case, we do not have that kind of situation because it doesn't touch. So we cannot get a factor. But we can express it using computing the square and only talk about the vertices. Understand? So you will notice that for the entire function, this is always positive. And that reminds you of what? another option. Look at this function. It tells you something, and that reminds you of something that we did. Somebody mentioned it today already. Positive definite. That's why we call it positive definite, because it is never negative. And you can see from the shape of the graph. That's why positive definite is when you have the minimum form of the quadratic function, which means a must be greater than 0. And when your discriminant is what? Your discriminant is less than 0. So a greater than 0 tells you is this shape, concave upward. And discriminant less than 0 means it doesn't touch. Am I making sense?
Yes.
So they are all positive. So in this case, you can see the sign diagram only has one sign. For the repeated factor, the sign diagram also only has one sign. Because it only touches. It only touches. It touches, instead of crossing to give you an opposite sign, it just goes back immediately. Do you understand? It's like you peep through the door, oh no, Mr. Daniel is there, I'm going to run away. I don't want to do math. Of course, don't do that. Okay? But there's a difference between these two. Your sign diagram always take into consideration what has happened today, my friend.
No, it's okay.
Are you alright?
Just tired.
Okay. We are all tired. Okay. One thing that you must always show also in your sign diagram, as you will see very soon, you will show the point where it crosses, if there exists any. Or touches. It touches at 1. So that 1 will be shown. Okay? But here, it never touched anywhere. You see, nothing is shown. Where it crosses at 2 points, those 2 points are shown. We use a thick line to show that that point exists. It exists at that point. If we are talking about asymptote, remember, we always use broken line for that number. Do you remember that from rational function? So this is just an extension, or should I say the beginning of what we should have done before. Quickly. There is one thing you should take note of. Maybe I'll show you this demo. This demo, I think that was the reason I actually signed up to the computer. Can you see this? You see? It is positive. The function is positive, which means above, up to this point. And from this region to that region, it is below. So the sign diagram is still negative. Are you following?
Yeah. Yes.
And the moment it gets to 1, it becomes positive. At 1, the sign is what? 0. At 1 itself, the sign is 0. Because it's the boundary. It's like someone that is stateless. You don't belong to Macau, you don't belong to mainland, you're stuck. You understand that? So this is when you have distinct, you see, when you have distinct linear factors, it will alternate. The signs will what? Do you know what I mean by that?
Yes.
What do I mean by that? Positive minus, positive minus, positive minus. So normally, all you need to do is figure out 1 and alternate the rest. You can figure out something here. I'll show you what I mean by figure out 1 by just substitution actually. Once you get this one, you know the rest is alternate because you have 2 distinct, very important, distinct linear factors. If we are working with a cubic function, same thing applies. All right. In this case, a positive definite, you see, throughout, it doesn't even give you 0, right? So it's positive all through. Similarly, if that was a minus, in the case of the maximum, it's going to be negative all through when it is below. In that case, I do not expect you to tell me x is equal to 1, because x is nothing. There's no number on the x-axis indicated. The moment you indicate a number, you are saying it touches or crosses at that point. If it doesn't, there's no need. So please don't come ask me and say, oh, do I still need to show 1? Why do you want to show it? So I know you can write 1. I know you can write 1 since KG. Okay? The last form. See that? Gets there, it touches, it turns back. It doesn't cross to the positive side. So that 1 is indicated to tell you this is at 0. But then, it comes back to negative. So when you have repeated factor, you get the same sign. Understand? It could be positive, positive, it could be negative, negative. You get the same sign. But when you have linear factors, you get what? Alternating signs. Does this make sense, guys?
Yes.
So this is all about sign diagram. We will then use this tomorrow in solving inequality. But for today, this is what we want to use it for. If the question asks you for the sign, I hope your speaker is working in this class.
Yeah.
Okay, great. If the question just asks you to do sign diagram, ladies and gentlemen, the best way is to factorize first. Factorize and try to observe what you see. Do you get two linear factors that are distinct? Then you know you are dealing with alternating. Understand? And once you do your factorization, of course, with your factorization, you can tell the points where you get your zeros. Am I making sense? So you draw your sign diagram, you locate the point where you get your zeros, and there are how many regions? Three regions. You pick any region comfortable for you. Any region at all. If 0 is not one of them, you can pick 0. You remember, it's very easy to substitute 0, isn't it? You substitute 0, get your result. If 0 is in the middle, and you get positive, then you know the rest are negative, negative. If 0 is positive, then you know these are negative, negative. Do you understand what I mean? Raise your hand if you understand what I mean. Denise, are you confused?
No.
Okay, feel free to ask questions, or you can talk to Joe like you guys are exchanging ideas. Understand? If you factorize and you get repeated factors, then you know, oh, I'm going to get two regions but the same sign. Are you with me?
Yes.
If you are unable to factorize, listen, if you are unable to factorize, maybe it's one of the positive and negative definite ones. Because in that case, you cannot factorize. If you can factorize, it's going to touch. If you cannot factorize, it means it doesn't touch. Unless the roots are maybe surd form. Do you understand that? Maybe the roots are in surd form. So maybe I shouldn't say if you are unable to factorize. I will advise you to just check the b squared minus 4ac. Do you understand? Check your b squared minus 4ac. If you get less than 0, it means it doesn't touch.
Yeah.
Do you understand? And if it doesn't touch, just put either positive or negative depending on your value of a. This is where you test your positive and negative definite. Let me expatiate what I mean. Please focus here, everyone. Let's say I have y is equal to x squared plus x plus 1. I've cracked my brain. It looks like my brain is not working. And I know my brain is working. I can't find any factors. Don't panic. Just go about your b squared minus 4ac. And this is 1 squared, 4, 1, 1. Remember to use the bracket so that you are safe when you have negative. So you get 1 minus 4. Oh, negative 3. It means this is one of those whereby if you have this, it's either this way or this way. You understand?
Yeah.
But how do you know which is this one? A. Okay, I was going to ask either Ryan or King. It's all right. So A will tell you, right? A in this case is 1. So will it be the first one, Ryan, or the second one? With A being 1.
A is positive, so it will be 1, right?
It will be what?
1.
Do you agree with him?
Yes.
A round of applause, please. It's the first one. So when you're drawing your sign diagram, all you have to do is what? Oh, all of them are positive, isn't it? You put positive, your x-axis, that's all. Okay? So your discriminant is very useful here. That's the point I'm trying to make. But in some cases, it is obvious. It is trivial that, oh, this will be factorizable. You have to also take note of this kind of question. Let's say you have x squared plus 3x, let's say minus 5. Again, clearly, there are no factors of 5 that gives me this. Right? So it looks like, oh, maybe it won't work. Maybe it's this one that doesn't touch. Don't be too quick to judge. Check your discriminant again. Let me change this to minus so we can be very careful with negative. Can you see that?
Yeah.
Minus 4, 1, minus 5. This is 9 plus 20, 29. What shape is this? Does it cross, touch, or never? Say that again? It crosses. The only reason you are getting 29 is because these roots are decimal form. Am I making sense?
Yes.
So you know it's probably going to be this one. Don't talk. I'm going to ask someone. Or this one. So let's call this graph 1, graph 2. Anika, which one is this? Graph 1 or 2? Again, what determines which one? Everybody, what determines which one? A. So Anika, with that information, which one is this question? Say that again? Do we all agree it's number 2? Close. It's number 1. Your A is positive. Remember what Ryan said earlier also. When your A is positive, it's the minimum 1. Alright? So if you are interested in what these are, then you use your formula method. And you can leave your answer in square root form. We have done solid in this class. So I do not expect decimal. Understand? Then you can have maybe 1 plus root 2, 1 minus root 2 as these regions. We'll talk about that more in the inequality tomorrow. But today we just want to focus on the sign diagram. Okay? And most of the questions do not need finding square root of 29 and all that. So it's just normal stuff. So I just needed to know that even if it doesn't look factorizable, that does not mean you should conclude that it is this form. It may be this form in disguise. Okay? So let's listen to this for more information. Then you are good to practice. Everybody focus. I thought I'm playing already. Oh, not yet.
We use sign diagrams to show the values of the variable x for which a function is positive, negative, 0, or undefined. For functions written in factored form, we can usually draw a sign diagram without graphing the function. In part A, the quadratic function is given in general form, so we first need to factorize it. There are no common factors and no special form, so we use sum and product factorization. 3 and minus 1 have product minus 3 and sum 2. So the quadratic has linear factors x plus 3 and x minus 1. Applying the null factor law, the zeros of the function are minus 3 and 1.
Opposites.
So,
Okay.
on a number line representing the x-axis, we draw solid lines at x equals minus 3 and x equals 1.
The smaller number
To
first.
determine the sign of the function when x is greater than 1, we substitute any number greater than 1.
Any number.
In this case, we choose x equals 2. Both factors are positive, so the function is positive, and we place a positive sign for x greater than 1. Alternatively, you could recognize that the coefficient of x squared is positive. This means the quadratic must be concave up, and so for large x, it must be positive. A linear factor that is raised to the power of 1 is called a single linear factor. The graph cuts the x-axis at the 0 corresponding to the factor, so the function changes sign at this point. X plus 3 and x minus 1 are both single linear factors. There is a change in sign about each 0, so the signs on the sign diagram alternate. In part B,
Before the part B, let's listen again. You substitute, you get this one. You don't need to think too much because it's linear, just change the alternative like I said earlier.
Do we
Okay.
go straight to the last step after we get that one?
No, this is all I need. This is just explanation. It doesn't mean you have to draw it twice. Your factorization, you get your zeros, you draw this line, you show this, you substitute, maybe somewhere by the side or below, it doesn't matter, but always make sure this is the last one, okay? Because you already know you're having minus 3 and 1, so either you substitute something before minus 3, between them, which is 0, is an option, or above it. And the author says something about, oh, this is the minimum one, right? if you picture minimum curve, you can easily tell that in between these two linear factors is when you have negative. It is it's a general thing, right? It's public knowledge. And above it is always positive. Below -3 is always positive as well, because it's going to be like this. So you can always picture it. Okay? So if I give you like a multiple choice or fill in the blank, or you don't have to substitute first, you can always picture this in your mind. Of course, if I need you to show me workings, you can't tell me, oh, I picture it in my mind. So I better just substitute something. Okay, so let's listen to the last one.
The quadratic is already given in factored form. The only zero of the function is 3, so we mark this point on a number line. To determine the sign of the function when x is greater than 3, we choose to substitute x equals 4. We see the result is negative, so we place a negative sign corresponding to all x greater than 3. Alternatively, you could recognize that the coefficient of x squared is negative. This means that the quadratic must be concave down, and so for large x, it must be negative. This function contains a linear factor which is squared. When a linear factor has an even power, the graph touches the x-axis at the corresponding 0, but does not cross it. There is therefore no change in sign at this point, and we place a negative sign for x less than 3.
Alternatively, this bracket, excluding the -4, what can you say about the sign for all x? Yes, sir.
It's always positive
Why do you say that, sir?
because it's a square.
Because it's square. Bring your x from anywhere in the world. Once you get into the bracket with -3, whether it is positive or negative, you don't care who wins the match between the x and the -3. There's always a bigger boss square that just turns everything to positive. So this factor, this part of this product is positive, which means this coefficient determines whether positive or negative. That's another way to picture it. Understand? And that negative tells you, oh, it's going to be like this. Right? It's a maximum. But it's always going to be below. Understand? So that's all about sign diagram. In the first, I have here 5, question 1 to 5. I classify them in 5 groups. I'll put on the light now. I classify them into 5 groups. In the first group, the graph has been drawn. Can you pass this? I'll keep this one, so I'll give you this. Just pass the rest. Kelly, from here. Pass to the back. In the first group of questions, the diagram has been drawn. All you have to do is draw the sign diagram either below or by the side. In the second group of questions, it is given in factorized form. So no need to stress yourself. Okay? It's been factorized for you. So whatever method you want to use, either you substitute or whatever, I think substitute is better, okay? And the third one also is in factorized form but in square form. But in the last 2 questions, 4 and 5, they are not in factorized form. So you need to figure out factorize and do whatever, okay? Wait, who doesn't have one?
Us. So,
Yeah, I asked him not to take one because I said I'll give you this.
my God.
So which means somebody doesn't have at the back.
Oh, no, the Carter doesn't.
Oh, okay. So we have just 3 minutes to the end of the first session. Can we turn on that, please? Turn off that. And Joey, you can turn that off as well. Thank you.